Our research is in the area of intelligent robotic perception and is titled Unsupervised Learning for Omnidirectional Infrared and Visual Sensor Fusion. Our block diagram has three goals. 1. The calibration of the omnidirectional infrared camera. 2. An improved vegetation and material detection. And 3. Semantic reconstruction of the robot's environment. Our first goal is to simplify calibration board centroid capture by using the four corners of the capture board grid and finding the geometric center of the capture grid, then converting this to a spherical coordinate. We will then use the direct spherical coordinate geometry to provide a more robust, accurate, and lower computation time methodology for the calibration of infrared omnidirectional cameras. Shown here is the spherical geometry of the camera. And finally, a sample of the captured calibration geometry. Our second goal is to improve vegetation detection and provide a robust, unsupervised feature learning tool for 2D material feature extraction, utilizing a sparse autoencoder feature extractor with two inputs, one from the omnidirectional infrared camera, extracting the thermal region properties of the different materials, and the second, the input from a visual camera utilizing the color index as the filter to capture the materials. These two inputs will then be fused using the autoencoder. Our third goal is to improve robot perception through the use of a convolution neural network deep learning process to provide semantic scene reconstruction. This will allow the robot agent to better understand the semantic construct of its environment and enhance the accuracy of semantic mapping, path planning, and scene reconstruction. We will first utilize optical flow through a color map representation to identify the movement of the robot and the objects in the environment. This approach will use the color to map flow, intensity, and direction to the color map key, with the quadrant representing direction and the color intensity representing magnitude. We will then apply a convolution neural network to classify and semantically overlay the different material types on the environment. Our research summary: we have demonstrated a more robust direct spherical calibration of the omnidirectional infrared vision system. We have also demonstrated fusion of omnidirectional infrared and Microsoft Connect color vision, and are going to work on getting color 360 degree camera vision as well. Our plan is to implement a sparse autoencoder feature extractor and implement the convolution advanced neural network classifier and semantic hierarchy model to demonstrate our concept and hypothesis.